Math 2, Unit 7, Review Worksheet. Alright, the first five problems are all Pythagorean theorem. We've had a lot of practice with that. It should be x squared plus 8 squared equals 12 squared, or x squared plus 64 equals 144, which means x squared equals 80. We take the square root of both sides, and we get x equals the square root of 80, which we should always try and simplify. So we put that into our calculator, 80, we hit enter, and we get 4 root 5. So x equals 4 root 5. Over here we have x squared plus 15 squared equals 17 squared. The hypotenuse is always c. So x squared plus 225 equals 289, which means x squared equals 64, which means x equals 8. Moving on to number 3, the length of two legs of a right triangle are 2 root 3 and 5. What is the length of the hypotenuse? So that's 2 root 3 squared plus 5 squared equals c squared. Or 2 squared is 4, square root of 3 squared is 3, 4 times 3 is 12, plus 25 equals c squared, which is 37 equals c squared. We take the square root of both sides, and we get c equals the square root of 37. Alright, 4 and 5, checking to see if these guys are right triangles. The biggest side should be c, so that is 3 squared plus 8 squared equals 11 squared. Or 9 plus 64 equals 121. That's a no, they are not equal. Over here we have 4 squared plus 10 squared equals 12 squared, which is 16 plus 100 equals 144, and those two are not equal as well, so no right triangles there. Okay, 6 through 9 are special right triangles. These two are 45, 45, 90s, and these are 30, 60, 90s. So starting here, if we know the one leg length is 13, we know x is 13 as well, because in a 45, 45, 90, it's an isosceles right triangle. And if this is 13, then y is 13 root 2. Okay. If this leg length is 3 root 2, then this leg length is 3 root 2, because again, it's an isosceles right triangle. And y is simply the leg length times root 2, or 3 root 2 times root 2. Square root 2 times square root 2 is 2, and 2 times 3 is 6. All right. Number 8, this is a 30, 60, 90 right triangle. If the short leg is 5, then the long leg is 10. The hypotenuse is twice as long as the short leg, and the long leg is simply 5 root 3. 30, 60, 90 again. So if the long leg is 12 root 3, we know the short leg is 12, because 12 times square root 3 will give you the long leg. And 12 times 2 is 24, so we know y equals 24. Okay, moving on. Alright, so find the measure of angle A to the nearest degree. Alright, so angle A is our reference angle, so this is opposite over hypotenuse. So the sine of A equals 3 over 7. So when we're looking for the angle measure, then we use inverse trig. So A equals the inverse sine of 3 over 7. Put that into our calculator like this. Use the second key to get inverse sine, and then we simply go 3 divided by 7, and we get 25.3 to the nearest degree gives us A equals 25 degrees. Okay, in this case we have opposite and adjacent, which means the tangent of A equals 4 over 13, which means A equals the inverse tangent of 4 over 13. And again, into my calculator, I go second tangent, gives me inverse tangent, 4 divided by 3, and I end up with 53.1, or simply A equals 53 degrees. Okay, moving on. Still A is our reference angle, but this time we have adjacent and hypotenuse. So that's the cosine of A equals 5 over 8. So A has got to equal the inverse cosine of 5 over 8. So into my calculator it goes. Second cosine gives me inverse cosine 5 divided by 8, which equals 51.3. So A equals 51 degrees. Moving on. 13, 14, and 15, find the length of AC. Okay, so that's this right here. And we have our reference angle, which is opposite over adjacent. So the tangent of 23 equals x over 12. X is on top, so we cross multiply. X equals 12 times the tangent of 23. That means 12 times the tangent of 23, and we get 5.09. We're rounded to the 10th, so we'll call it 5.1. All right, we still have the same reference angle and the same sides, so this is the tangent of 84 equals x over 3. X is still on top, so we cross multiply. So we get 3 times the tangent of 84, and we get 28.5. And finally, we have still the same reference angle. We have opposite over hypotenuse, which is sine. So the sine of 40 equals x over 71. X is still on top, so we cross multiply. We get x equals 71 times the sine of 40. In comes the calculator. 71 times the sine of 40, and we get 45.63 or 45.6. Okay. All right, moving on. Number 16, determine which of all the following equations are true. So sine A would be 5 over 13. That's a no. Sine B would be 12 over 13. That's a yes. Cosine A would be 12 over 13. That is a no. Cosine B would be 5 over 13, and that's a yes. Number 17, which equation could be used to find x in triangle ABC? Well, here's our reference angle, so it's opposite and adjacent, so that's tangent. So I'll write the tangent of 27 equals x over 12. X is on top, so I cross multiply. I get x equals 12 times the tangent of 27. And I look over here and I see that it is C. Moving on, number 18. Which expression can be used to find the value of x? All right, well, reference angle opposite over hypotenuse. So that's the sine of 50 equals x over 3. Still have x on top, so we cross multiply. X equals 3 times the sine of 50. Whoops, 50. Okay? All right, so right here we have x equals 3 times the sine of 50. So that is our answer right there. Okay, moving on. All right, so these are very important questions because they talk about the relationship of sine and cosine, and you will see this on your test on several questions. So which of the following equals sine of A? Okay, so sine of A is opposite over hypotenuse, and the cosine of C is adjacent over hypotenuse. So you can see that cosine of C is equal to the sine of A. Very important concept. Okay, which of the following equals the sine of A? Again, sine of A is opposite over hypotenuse. So the what's equal to the sine of A is the cosine of C. Because again, cosine is adjacent over hypotenuse. You can see those arrows match up. Alright, so this is a good one. You're definitely going to see one like this on your test. Identify all the equations that are set up correctly to find x. Well, right off the bat, this is our reference angle. We could say the cosine of 40 equals x over 35. Cosine of 40 equals x over 45. Very good. Okay, but if this is 40, we know this is 50. So we could say cosine of 40 is equal to the sine of 50. So do we have the sine of 50? There it is. The sine of 50 equals x over 35. Okay. Are we good there? I think so. All right, moving on. Number 22. When I see a word problem, I automatically thinking I should draw a right triangle. So this one is a television screen. So there's my television screen. Television screen measures approximately 15.5 high. Oops, well, I guess I'll do that again. 15.5 high and 19.5 inches wide. A television ad is advertised by giving the approximate length of the diagonal. So here we go. We can put 15.5 over here. There's my right triangle. I'm looking for C. So that is C squared equals 15.5 squared plus 19.5 squared. That seems like some tough math, but it's actually pretty easy when you have this great calculator. So we'll go 15.5 squared plus 19.5 squared, and we get 620.5. So C squared equals 620.5. A little trick here, we can take the square root of that by going second square root, and then you see this A and S, and we hit enter and we get 24.9. We wanted to round off to the nearest whole inch, so we will say the answer is 25 inches. Alright, a tree casts a shadow, so here's my tree, there's my shadow, there's my right triangle. A tree casts a shadow that is 22 meters long at a certain time of day. The angle of elevation is always looking up, of the sun from the tip of the shadow is 47 degrees. What is the height of the tree? Alright, so there's our reference angle, and it's opposite over adjacent, so the tangent of 47 equals x over 22. X is on top, cross multiply, x equals 22 times the tangent of 47, which means x equals 22 times the tangent of 47, and we get 23.59. What is the height of the tree? We'll round it off to 23.6. And 47, and over here this has got to be 43. So we'd expect this to be a little shorter than the height of the tree, and it is a little shorter than the height of the tree, so that makes sense. 24, a 22-foot ladder is leaning against the side of a building. If the angle formed between the ladder and the ground is 75 degrees, how far is the bottom of the ladder from the base of the building? So here's our reference angle. We have adjacent and we have hypotenuse. So that's going to be cosine of 75 equals x over 22. X is on top. We cross multiply. And we plug that into our calculator. So 22 times the cosine of 75, and we get 22 times the cosine of 75. We get 11 root 6 minus 11 over 2. That doesn't look very helpful, but this is a time I'm getting something weird. I'm going to double check. Okay, 75 adjacent over hypotenuse. Makes sense. So cosine of 75 equals x over 22. I cross multiply. That looks correct. So I check 22 times the cosine of 75. Looks good. So I hit this button and I get 5.69, or could round that off to 5.7. And that seems to make sense. 22-foot ladder, that's a 15-degree angle. We expect it to be kind of short, so that makes sense. Okay, so x equals 5.7 feet. Okay, last one. We have a reference angle of 50. We're looking for the opposite side, and we know the hypotenuse. So that is going to be the sine of 50 equals x over 200. Again, x is on top. We've given that to you a lot. This test or practice test or review, I wouldn't count on in the test. We'll probably mix it up more. But 1 times x is x. 200 times the sine of 50. And into our calculator, 200 times the sine of 50. Enter 153.2. So x equals 153.2 feet above the ground.